Welcome. In this channel, I do unscripted, unedited videos about Linux programming and stuff. In recent days, I have been just starting to relearn C. It's been 25 or more years since I've used it. I've also kind of gotten distracted with the build system, makefiles, CMake, Nix build. A lot of interest there. This video will be down that path. I'm going to be taking a look at the process of building an absolutely minimal Docker container. I've kind of experimented this with a little bit prior to this, and I'm going to walk through it again. I'm trying to define the process in my head so that I can eventually script this process for doing this. The basic idea that I want is to be able to have, as part of my build process, I just pass the executable to a script, which then generates a minimal tree structure, the minimal file structure in a folder that eventually then gets copied into the Scratch contents of a Docker container. And like I said, I have experimented with this. Let me see if I can remember where. Oddly, I was doing this I was sidetracked I was working on some Nix stuff, and I got sidetracked thinking about how to do this. It ended up, this little experiment ended up over here. But what I'm going to do is just do this over. So I don't need the first attempts that I did at this, which really were less correct. I'm going to that is interesting. What do I got going on right here? It looks to me, oh, they are spelled differently. Sorry, I couldn't see it at first. SCSR, yeah. So some weird mistake I made, a spelling mistake I made in my previous experiment. Okay, so the idea is basically this. I have a Docker file, and I mean, really, we can ignore that, and we can ignore that. So this is the entire Docker file. What I want to do is I want to build on the file system a folder called Scratch, and inside of that folder I want to put everything that's required to run this demo program and absolutely nothing else. And then I have a minimal container. So if I take a look, the program that I've been playing with, my particular project, is this is on the path. So it's installed in local bin, and if I run it, it outputs a little bit of stuff from a few libraries, or a few function calls, and then asks for my name. Okay, so that's all it does right now. But I want to run that in a Docker container and have absolutely nothing else in there. Well, the first thing I know is I need to have all of the files that it's linked to also in that Docker container, and I can find those. I can find what those files are by looking at just calling LDD on the thing, and it gives me the list. Okay, so what I'm going to do is we're going to create a script called make scratch. And it is going to build up this eventual root tree, file tree that we need. And these are all the libraries from that are included in the demo program. Well, the first thing, I'm going to be rerunning this as we do it to make sure that it's correct. So the first thing I'm going to have this script do is delete the Scratch file, the Scratch folder that we're building, and then remake the Scratch folder. But I know that I'm automatically need to copy in the demo program. So what I'm going to do is I'm just going to have it do create Scratch user bin demo, or user bin, right? And then what we're going to do is we're just going to copy from my file system wherever demo is into scratch user bin. And the last thing I'm going to have it do is just output scratch so we can see what's in it, right? So if I chmod plus make executable make scratch and then run make scratch, we can see that it's starting to build up the file system, right? The very first thing we need in that file system is the executable we intend to run. The next thing we need are all of these linked libraries, these shared objects. So to do that, what I'm going to do here is we're just going to walk through these one at a time. So oops, I want to put this here. I want the scratch. I want to have the output be the last thing that happens every time we run it. Okay, walking through these and breaking them down. Okay, I need to turn off Copilot. The first thing is this Linux VDSO file. It turns out that this is a shared do nothing. This is a shared object file. So so this file, I had to look it up. It doesn't exist on the file system anywhere. It is provided by the kernel. It appears as a shared file object that everything links in. So there's just nothing to do for that one. Walking through the next file, right, is this lib YAML. Now, what I've come to realize is this is just telling me that this is the way that the symbol appears in the linked in the executable in demo, but it's referring to this thing on path on disk, right? So the way that we get this into the into our file structure is I need to copy something to scratch that place, right? The thing that I need to copy, the file that I need to copy, is going to be the real path of that thing. That thing might be a symlink. And if that's the case, I don't want to have to follow a whole tree or a whole chain of symlinks. So instead, what I'm going to do is I'm going to take the real path of this thing, right? Actually, let me do it this way. So I'm going to take the real path of that. Actually, I could just do it, right? So if I do real path, so what I really want to do is real path of that thing and copy it to that same path, but with scratch prefix in front of it, right? So if I, the reason that didn't work is we're missing we're missing the folder structure, right? So I need to have lib x86 Linux GNU must exist for it to copy that in there. That still did not work. Why? It was okay. So the real path works. So if I cp real path okay, run that in a subshell, get that, copy it to here, but with a scratch prefix, right? So it's telling me no such file. So does lib x86, does this not exist yet? And that is exactly the mistake I made. We need to make that lib x80, we need to make scratch lib x86 whatever exists. So now if I run this, we can see that we copied in this lib YAML file, which was our dependency, which was our linked. So I'm going to move this up here. This is there's a limited number of library search paths, and I'll add them as we run into them. Okay, so first file, the first file, we had nothing to do. Second file, we take the real path of it and we copy it into the scratch, and we continue that for each of the files. So for this one, this is the actual file path. We don't need to know about that. And what we do is we cp real path oops. So we cp the real path to scratch prefix real same. Oops, nothing, right? So now when I run make scratch again, we didn't get it. We must have a different prefix going on here. So this one is lib x86 GNU lib x. Those look identical to me. This one was libc. Okay, so let's manually walk through this. Does the real path part work? So the file doesn't even exist. Did I mess up the file name somehow? So if I LDD which demo, the file we're messing with here is the libc6 one, which should be, oh yeah, somehow, did I really? Oh, I think, yes. The part we're missing is just another library, or is another search path prefix, right? So, no, that's the one that's up there. Those are identical. Why am I confused here? Oh, deleting slash was missing there. Yeah, this is putsy for sure, doing it manually, but it's still proving out the process here. So now I properly have the libc in there. I have demo, libyaml, libc, and if I just continue with this process, it should work. The actual path for the include the linked library is that. So if I take cp real path, that thing, and I am going to copy it to there, but with scratch prefixed. And now this time libx86 is the prefix. Libx86 prefix already has the path getting made. So now we have the SQLite part. Okay, this next one. So we need to cp real path that thing. And We need to copy it to Scratch. Oops, let me grab that again. And we need to copy it to here. Now, this is the one where, notice this one's in the folder lib64. We are not making lib64 up here, so we need to grab this, grab that, make directory P, scratch lib64, but we can leave off the file part. Now, if we, so now we have the lib64, it's included here. And let's just continue to build this up. We need this libm file. So, okay, let me do that this way. This is the file that we're actually, the linked shared object we're trying to include. That's it. We need to cp real path that thing into scratch that thing into there. And now this time it's libx86 still. So we're copying it into libx86 still, so no issues. Okay. Make that. Okay. So now we have, whoa, I don't see it. We were trying to make libx86 something or other libm. I do not see a libm. libx8664 coming from Sketch doesn't exist. There we go. So now we have the libm file. Now technically, I think we have to do all of these recursively. So let's so if I LDD which demo, and I would technically have to include any, I have to do this recursively then. So I have to say LDD on that file, which includes the virtual one, which includes libc, which we already have, which includes lib64 LD, this one right here. Okay, so we have everything for libyaml. Now, if we LDD this one, it has the LD64 file, we have that. It has the virtual file, we have that, so we're good. So now if we, so we have the YAML, we have everything for that one. So if we look at the SQLite shared object, and we do LDD that thing, it has the virtual file, it has a libm, which we know, that was the last one we just did. It has libc, which is there, and it has the lib64 file, which is also there. Okay, so we have that. Finally, if I look at the lib64 file, that thing is statically linked, so it has no. And then finally, if I look at this libm file, which is here, it has the virtual file, libc, and the statically linked file. So walking it recursively, we have everything. If we tree into Scratch, this should be every single file that's required to run the demo. Now, to build that, all I need is the Docker file, right, which we have. It's just from Scratch, copy everything from Scratch into the root, and then execute it. To do that, I need a Docker build. We're going to name it foo in this context. Yep. So, and then to run that, Docker, not docker run rmit foo latest, and it executes. So now docker images, if I take a look, we can see we have a 6.9 megabyte image. And let's compare that to, actually I just stack give it to you. So the original file size was 4.8 megabytes. And we ended up with a 7 megabyte. And that overhead is, the container layers and stuff, which probably can be shrunk. That's another thing to go research. But it's pretty fixed. You're going to always get about that 3. Right now, I would always get about that 3 megabytes doing a single layer from scratch file. There's not much more. That wouldn't change by much. It could probably be shrunk a little. I don't know. That is kind of what I was after, which was to kind of prove out the process. Now, obviously, I'd actually have to script this, and it has to walk through these things recursively. And then the other thing that a person has to be aware of is this works because that particular program doesn't use any other file in the system. But anything that uses networking, for example, is probably going to try and read the host file. It's probably going to try and read the resolve stuff. Or anything that has to reference a user is going to look in the etc. password stuff. Programs might be using the locale stuff in share. And you have to take all of that into consideration. I originally was hoping to thinking I could, build a executable that would take like a deb file and spit out a minimal container. And you could, but it wouldn't be as minimal as I'm after. Because it's hard to tell everything that a program would use. Everything that's considered that essential layer that's kind of just assumed to always be there, like the etc. password and whatnot, the program itself never tells you that it's dependent on it. There's no way to know it just by looking at the program. You have to know it from running the program or whatever. Okay, so I can't turn a deb file into a container, but that doesn't mean that I can't write a script that I can make as part of my make process, my build process, that does it. So imagine a little tool that I pass. So I run my normal build process. It would have a make install that would know how to install all the pieces. You make install all the pieces into the Scratch folder. And then you additionally find all the linked libraries for those pieces. And that's the entire thing then. Because now all those missing pieces... Okay, so it's still missing like etc. password. And so probably the way to fix that is just give yourself some command line tools in that little script that says, hey, add a user or add the basic networking files, or just always put those things in there because they're so damn tiny. They're going to be like less than a few hundred kilobytes probably. And they really aren't going to make a material impact into the container that you're making. Anyway, this was kind of just a little dive down a rabbit hole. My eventual goal is probably to have something like this baked into my build process because my delivery unit is almost certainly going to be a container. And I just kind of wanted to explore it. So I guess that's all for this video. I will see you guys next time.